Hello everybody, welcome. This is paper 1 from November 2023, time zone 1. Let's work through this and see what we can do. So far it's been pretty heavy algebra test and the questions have actually been quite challenging. I gotta say. Now we're into some statistics. I think it's still actually a challenging paper, not gonna lie. Okay. Question 9. Miss Whitehouse is a chemistry teacher. After grading her final exams, she creates the following box and whisker diagram to compare the grades of her two classes. Identify which, we have class A and class B. Identify which two of the following statements must be true according to the box and whisker diagram. Indicate your choices by placing tick marks in the second column of the following table. Alright. The data for class A is normally distributed, which must be true, not necessarily the case. A normal distribution looks like this, and if that was the case, we would expect symmetry, and we don't see symmetry here, so not necessarily the case. No, there's two that have to be true. A higher percentage of students in class A received a grade less than 30. Higher percentage of students class A received a grade less than 70 on the exam. Higher percentage class A received a grade less than 70. So here's our 70 right here. So what do we know? We know that a box and whisker diagram divides things up into quartiles, where each of these sections is 25%. And what do we have here? Less than 70. It's possible that all 25%, it's possible that all of these students are right here, right? That, I don't know how large the class is, but we could imagine that all of them got a grade well below 70, that all of the 25% is clustered here. What we know for class A is that 25% and potentially at least one, right? Potentially they're all here, and then there's one person here. But we know that there's part of this 25% group got a grade of less than 70 by definition, or it wouldn't end here. So yes, this is true. A higher percentage of students in class A received a grade less than 70. More students in class B received a grade greater than 90 on exam than class A. More students in class B received a grade greater than 90 on the exam in class A. What do we know? We know the highest grade was in class B. It has a higher maximum. But is it necessarily the case that more students in class B received a grade greater than 90? This is a grade greater than 90. It's possible, remember each of these represent 25%, it's possible that we have all of these students right here getting grades of like, 88 or so. And there's just one student here that gets a grade of 98 or something like that. It's possible. And it's also possible that all of the students in this class, for example, since it represents 25%, all we need to ensure is that 25% of the data here is within this quartile. It doesn't tell us about how it's distributed, and we can't imagine that it's distributed evenly. We can't imagine that it's equal like this. It's possible that, for example, for class A, that more students in class A received a grade greater than 90, just based on the distribution. We don't know the distribution. We know that 25% is clustered here. This could potentially be a little higher. The interquartile range for class B is less than the interquartile range for class A. Interquartile range, Q3 minus Q1, here's Q3, here's Q1. This is smaller than this. Interquartile range for class B is less than the interquartile range for class A. Alright. Not bad. There we go. At the end of the year, Miss Whitehouse surveyed a random sample of students from each of her two large classes to determine how satisfied they were with her teaching. Each student independently selected a value from 1 to 10, with 1 meaning that they were not satisfied at all, and 10 meaning that they were very satisfied. Her collected data from the student surveys is shown. Okay, so here's class A, and here is class B. Miss Whitehouse believes that there was no difference in the general satisfaction, so no difference in the general satisfaction between the two classes. She assumes the data is drawn from population, normal distribution, and proposes to conduct a t-test for the 5% significant level. All right. So she wants to do a t-test. Normal distribution, this just means pooled is equal to yes, which it always is by and large. I haven't seen one that wasn't. Pooled is equal to yes for our t-tests on AISL. Write down the null and alternative hypotheses. If we're calling this UA or U, we can call this U1 or UA, doesn't matter. Let's call this mu A and mu B. Null hypothesis, let's write it here, I guess. HO and H1 or H alternative. We're saying that this is the status quo, that there is no difference. And the alternative is that mu A does not equal mu B. That's our alternative hypothesis. Jenner is kind of 2 marks. Find the p-value for her test. Okay, we know it's at the 5% significance level. That comes later. Find the p-value. Let's go into the calculator screen and work this out. Go back to spreadsheets. Let's set a value for x and y, or class A and B, and let's input the values. 7, 5, 3, 4, 3, 8, 6, 5. All right. And here we have 6, 9, 8, 10, 1, 9, 10, 9, 8, 3. So it doesn't matter that there's 2 more values here. Menu, statistics, stat test, sorry. We want to do a 2-sample t-test. X is in our X, Y. Y alternative is the differences are, there is a difference in the average kind of satisfaction rating. Pooled is always equal to yes. Pooled is always equal to yes. There we go. Let's go down and find the p-values. Here it is. Okay, interesting. So let's go back to the document screen just in a sec. P-value 0.0952. Okay. So write down the p-value for the test. See, p-value is equal to 0.0952, the 3 sig figs. Part D, write down the conclusion of the test, give a reason for your answer. So general structure for this, we write 0.0952, or our p-value compared to, where is it, our significance level. And in this case, our p-value is greater than 0.05. If you want, you can write this out as 9.52% is greater than 5%. And then what does that mean? Our p-value is greater than the significance level, so we fail to reject HO. Can you write except? To be honest, I'm not sure. I haven't received kind of clarification on whether you can write except to be absolutely safe. Fail to reject the null hypothesis. We can't reject the idea that there is no difference in this case. Or we, in another way, accept the idea that there is no difference. We fail to reject it. P-value greater than the significance level, accept the null hypothesis, or phrased differently, we fail to reject the null hypothesis. And this is our justification. Alright, let's keep going. So here we get into more statistics probability. Rita is playing a game. In the game, she must roll a fair 6-sided die. I'm sorry, I'm just going to go back 1 sec and just to make sure that there was no context. Write down the conclusion of the test, give a reason for your answer. No, in this case it's okay. I was just thinking sometimes they do ask, for contextualization. In this case, there is no significant difference between the satisfaction between Class A and Class B. In this case, they just want us to write down the conclusion and give a reason. So here's our reason, this is the conclusion. Alright everybody, I hope that was helpful, and as always, best of luck. Take care.